All right, hello everybody. This is Antonio Wolf doing up another interview with Avalonia. If you all remember, we did an interview. I forget how long ago. Was it almost back in December, somewhere around there? Well, it was in November, and I think I put it out like somewhere in December. So it's been a little bit over half a year over the philosophy of nature. Uh, this is also related, but it will be a bit more structured on more specific questions. Because a fan of yours had asked me, like, hey, can you ask him this? Would you do an interview about that? And I'm like, well, we could probably do that. Just get a few questions for more scientifically minded folks, and let's see what we can do. So, right, Avalonia,
Yeah,
we'll just
sounds
get
good.
off to the questions. So, first question: what is a philosophy of nature? Why should we care so much? Is empirical science not good enough to understand the world?
hmm Yeah, so basically, and how I see the philosophy of nature is, at least how I would define it, is that it is the systematic and objective exposition of nature's concept. So its main task and purpose, compared to uh, as for anything that wishes to call itself science, is to uh, rigorously prove the concept of what it is. And for those of you who may be familiar with this or with the Hegelian terminology, some of you may have, some of you might not, but the concept specifically is extremely significant and even primary for philosophy, because only it can satisfy the closure and completeness of explanation. Because what it posits as a premise uh, ought to reason from itself out of that premise to the conclusion that justifies the original premise posited. So the concept is, you could say, um, posits itself, or is the cause of itself. And what the philosophy of nature, uh, at least in the aim of the philosophy of nature and what it's trying to do, is to show how, or to let the concept of nature explain um, what what it is all about. Now, um, as far as uh, current philosophy goes in the modern day, uh, there has been an enormous amount of progress, and progress in the sense of many scientific discoveries after Hegel's time, and uh, there has been a lot of progress both in the sense of empirical discoveries, learning more about what things are in nature, as well as developing um, theories and models for understanding them. Um, but there is not a whole lot of uh, there's not a whole lot of genuine or philosophizing about uh, the philosophy of nature specifically. Like there are still very excellent studies on specific problems in in science or in physics. Um, but they're still very oriented to the problems that exist in individual um, specific topic areas, um, which, you know, the lack of philosophy or philosophical orientation in nature, there's some reasons for this. Um, there's, in some ways, it's kind of a result of some preconceptions or natural preconceptions about what philosophy and science ought to be like. And because of this, this is how um, people's approaches end up kind of being guided by what their assumptions are. And to to be able to reason from the philosophical standpoint um, requires you to um, essentially abandon these assumptions, or if you have some kind of uh, specific claim about what some object is or what something is as evidence of something, then it then you ought to be able to describe more fully um, what exactly that what exactly it means. Um, and in a lot of ways, you could say that the real reason why we should care about philosophy or philosophy of nature is because of the simplicity of explanation, like in being able to um, just to use your own um, human reason to reason about nature. That this is something that ought to be explained ought to be explained to someone um, who can simply reason about it just by going through the or thinking through the subject matter itself. Uh, and this is something that even though it can be done in a general sense in um, purely just in any sort of subject matter or topic area in uh, the natural sciences. Um, but to that extent, I think it is also possible to think of to use the speculative method or um, dialectics as directed towards um, other theories of physics as just a way of um, testing its own criterion against itself, because really the truth or the idea of truth in the Hegelian sense is uh, that true things are independently true uh, or are self generative. So um, it shouldn't depend on some relative or uh, external foundation or someone's opinion, or be a hypothetical or or just something that people believe. It ought to be able to so to speak, stand on its own 2 feet. And in a certain sense, um, in my view, I see empirical science as um, intimately connected to this, but um, in a certain sense, the at least one of the problems that I see with purely empirical methods when not in the sense of just making discoveries, but as a general approach to understanding nature, is that it's actually not empirical enough. It's not empirical about its empiricism, and in a certain sense, the the um, the idealist notion, and I mean idealism in the Hegelian sense of that finite things or things which are parted do not really have an existence for themselves. That you can kind of say that in a deeper sense that there is uh, uh, a deeper similarity between um, conceptual or speculative science and um, empirical science. So, in a certain sense, I would say that um, I would almost even advance maybe even perhaps a more controversial take that um, empirical science is not empirical enough, and that's kind of the problem.
Mhm. So, would you say that, in summary, like the importance of philosophy of nature is it is itself a conceptual science about the concepts employed in what we normally call science, and that a lot of these people take these for granted. We take for granted that we just know what space is. We take it for granted that we just somehow know what time is, or what atoms are, or what matter is, those kind of things. But in philosophy of nature, that's where we see whether those concepts are really up to snuff or not.
Yeah, I think that's a good summary of it.
All right.
I agree.
Well, let's move on to the next question. Actually, since we started with philosophy of nature, and you brought in a bit of philosophy of science, we'll skip to the philosophy of science questions. So, first one, many philosophers of science today accept the so-called indispensability thesis. That is, that we must be realists about unobserved theoretical entities insofar as they are intelligibly the transcendental condition for our observed entities and activities to make sense. Stuff like black holes, singularities, those kind of things. We say we accept those to exist because they seem to be indispensably tied to the other things that we do accept to exist. We accept the equations of general relativity work, and therefore, because those work and those kind of lead to things like singularities, whether we understand singularities or not, we accept that they're there. What does speculative philosophy have to say about this?
Hmm. So my my viewpoint on the indispensability thesis is, I think, the argument has some point in the sense that uh, the kinds of claims that one is willing to put forth about uh, nature in the sense of positing that some object or thing should exist because it is a consequence of um, this uh, theory and so on. Um, I, I think that the the thesis itself isn't really something that is self-evident and actually requires a deeper explanation. This is something um, compared to some other uh, Hegel scholars and readers of Hegel. I have an understanding of uh, a certain part of the science of logic as connected to uh, at least I'm more unique in this respect that I connect this more directly to how scientific theories are formulated. And um, I haven't published anything about this yet on my site, but it's something that I have planned. That basically what Hegel is talking about in uh, the subjective logic, the section on syllogisms, is perhaps the most informative way that is in fact the way that um, true scientific theories are actually constructed. And to comment specifically about some of the issue with indispensability is that I kind of see it as um, a more specific case of the general issue of taking for granted um, hypothetical inferences or essentially taking for granted uh, hypotheticals or pure hypothesizing as something that is a sufficient explanation in and of itself. So, uh, so as far as uh, at least with as far as Hegel is concerned here, um, basically the kind of structure of the hypothetical syllogism kind of comes from uh, the categorical or showing that it there is a dialectic at work um, between what Hegel terms the genus or the category and the species or the kind that of what kind the category is, and uh, the hypothetical syllogism essentially reasons from this point that it uh, it's basically saying that you can't really tell whether on its own whether the subject matter is the category or its kind, and that this is just sort of an external um, uh, it depends kind of on this external uh, reflection to set it as such. Which the kind of issue is that if you're saying that one of these things is the genus or category, and the other side is the kind or individual thing, you could say like uh, neither really the category nor the kind ends up eminently um, identifying itself as one or the other. So really, so really the way that this is something to be resolved is that the hypothetical syllogism has to itself yields to objectivity, or which is in a certain sense the formal completeness of explanation, which is pretty much what the disjunctive syllogism is, because the genus or general category is also coextensive with its kinds. So the category is itself a unity that is self-differentiated and reflexive. So it doesn't depend on the sort of kind of indeterminacy of asserting something as being evidence of something, because this hypothetical is something that says that it ought to be evidence, that it's not really you can kind of say in one sense, so in one sense it's one thing to say that something is a consequence of another thing, or ought to follow from another thing, but that just puts the the question of what really even makes that possible. So that's kind of that's basically what my viewpoint is regarding you know the status for the indispensability thesis of theoretical and observed entities in a very broad sense.
So would you agree that the problem can be phrased as one, we begin with a hypothetical, we begin with a model that we're not certain that this is actually the case, and two, we reach backwards from the top level of the model and then develop entities through different procedures of, whether it be some kind of some theoretical procedure, be it mathematics or some other conceptual scheme, in which we see some appearance, and then we're like, well, according to the top level appearance of this model, here's the things that may satisfy this. And then when we land on one that's, we like enough, or that we see coheres enough, we kind of jump the gun and say, well, this is it. And now it's indispensable. This is the only thing that can explain what we observe, when in fact it's not really the case, that, like, conceptually speaking, that really holds.
Mm-hmm. Yeah, and I think one good way to test that is really one of the most important things that can be done here is actually showing and testing that how it's not just straightforward that it is this particular thing that shows that it is evidence, but also the status of alternative explanations to things, because that's kind of just even, and that's kind of the way that naturally how hypothetical syllogisms tend to be resolved into something that is disjunctive or self-differentiated, because it, even though the hypothetical is something that is limited, it does technically imply or should imply those other um, alternative explanations. But the way to um, the way to approach that is to actually test and investigate them to see essentially to see which one is um, the the most accurate rather than just um, for instance like uh, arguing from like uh, tradition for example, or because this is kind of the way that or other forms of non explanation, where just kind of just takes it for granted.
Mm. All right, next question. So, you certainly heard this phrase: the unreasonable effectiveness of mathematics in the natural sciences. People use that to express what seems to me to be the general mystification which many great scientists, as well as like regular scientists, the people who do the grunt work, about why nature should be so well understood by a seemingly unnatural realm of abstract numbers. Hegel has a very unique answer to this. Can you explain that?
I believe you should say this in the it should be in the philosophy of nature
It's the very beginning with
somewhere.
a yeah.
Yeah.
At the very beginning, like he titles the first section, I think, of physics, mathematics, and his explanation,
Mhm.
right, is that he says, well, actually, space is just kind of basically embodied mathematics, quite literally. Uh,
Mhm.
it's mathematics is a self-external space, and nature is the realm of self-otherness, self-externality, and so why wouldn't it, be mathematical?
Mhm. Yeah. And actually, this is something that I've been doing some writing about, and I uh, haven't published this yet, but it's almost done. About this is something that I was thinking about for a while, and regarding the first part of the philosophy of nature, uh, because the first category is really the um, about externality, or basically the triad of space, time, and motion, basically. Um, but I was doing some investigation into this, and there was one of Hegel's students who continued writing in Berlin, and is also a one of the leading people in of classic Hegelian philosophy. Um, K.L. Michelet, or Carl Ludwig Michelet. He basically um, had was expanding upon and improving uh, the encyclopedia in various um, parts of it, to where he had his own edition and account of the encyclopedia, where you have logic, nature, and spirit. And he actually places history at the very end, um, which is uh, which is a discussion for another day, but is interesting in its own right. But anyway, he he actually has in his philosophy of nature, he actually describes the beginning of, you know, he has the standard categories of in Hegel, of space, time, and motion, but he also characterizes this part as itself mathematics. That he, or at least the way that he describes it is that mathematics in the real sense is nature, but it's nature in its most abstract and indeterminate aspect. And and explicitly he relates the categories of space to that of geometry, time, interestingly, to algebra or arithmetic, and motion to calculus or analysis. And he has quite a lot of interesting commentary on that aspect. But as far as my position on this is concerned, at first I wasn't completely sold on the idea, but increasingly I'm starting to see that mathematics in the true sense of in the true sense of the word, or real math, is nature, or nature in its most abstract or indeterminate aspect. Because even in thinking about or conceptualizing um, things in nature in mathematical terms, you are essentially stripping away or abstracting everything the um, from the determination of that object or thing, and are essentially, what remains is just, the very basic determinations of, like, you know position, placement, speed, the the body's spatial extension, what shape it is, um, the specific uh, rates of change in motion, things like that. And I kind of think that, you know, because, there is kind of a debate within, or at least among people who are Hegelians and scholars of Hegel, about, how exactly does the logic or the absolute idea become nature. And that's kind of something that, there's um, Schelling was one who kind of famously objected to that, and kind of went on his it kind of took that as justification for going on his path for that that this purely conceptual determination is something that's not complete, and that there's also positive philosophy is needed somehow to supplement it. But I think that Hegel's explanation is a more purely sufficient here, and uh, I think that Michelet actually makes a important contribution in this respect. I've been translating a lot of his. There's a lot of work of students of Hegel's and people who came after him who haven't really who there are basically no works in English. There's just the original German, and that's kind of been one of the other things that I've been doing, um, because I think that is very important to kind of uh, bring that knowledge to light.
No, yeah, it's very interesting stuff. Next question. It is a common belief among laity and a lot of rank and file scientists these days that a reduction of all fields to physics is not only in principle possible, but has actually happened to a significant degree already. Is this true?
Um, in general, no, because the way that really the grounding of all fields or subject matters in natural science to a particular natural science, um, you know, it just begs the question as to why that is even possible. And, you know, because if each subject matter is something that is a descriptive moment of nature, as a complete or total system, then um, that has to mean that each uh, field of natural science is related to each other by either by being descriptively included or descriptively including or being included by other fields. So in that uh, notion, um, there's the problem of reduction, of things of the kind of canonical sense that um, reduction of things in nature to because this is the same question that is sometimes posed, um, except instead of physics, they'll say that it's mathematics. But I, I can't help but think of the Zizek quote that space is literally the stupidest thing there is, which I mean, he's right. It's really the simplest and most indeterminate thing that, it's almost like you're looking at this way of looking at nature is almost like nature turned on its head, or it's like inverted because, in reality it's the simplest and most indeterminate basic things is like space, time, and motion. But at the very end you have the complexity and fullness of organisms living and interacting with each other in the environment, in the biosphere, and specifically the animal organism as a kind of unified and animated subjectivity is, that is something like that is basically the most complex natural entity that or most complex determination of nature that there really is. So I just basically, I guess to sum up is that it's really the exact opposite way that people should be looking at nature, in my
Mm.
view.
Yeah, yeah. Regarding that, with stuff like chemistry is usually considered like the next step of complexity above like a mere physics. And when I've had discussions with people that they are adamant, oh no, chemistry is physics, and I'm like, well, explain to me, why it is that we don't yet really have a general theory, for example, the electron arrangements, and like why certain things work in, I forget what the connecting electrons are, the valence electrons, those kind of shells.
Mhm.
Why are they specifically
Yeah,
that way? We don't know.
once.
They're just there. We can account for them only in like a description, but we don't really go like, well, here's gravity, here's matter, here's like the fundamental forces, and this is why atoms are structured the way they are. We don't really have that, and so it's just kind of, it's one of the strangest claims because even the science that's right next to physics, chemistry, can't really practically be reduced to it when you really look into it.
Mhm.
Um, and as you said, you basically answered the second question I had, which is, do we really even need to consider reductionism in this way when we try to think about the world speculatively? And as you said, yeah, actually, in truth, when you look speculative, you try to look at the world as it actually works and as it actually makes sense. It's kind of backwards to how most people seem to believe this is. It's the more complex things that end up being the explanation for simpler things. And also relating back to what you said earlier about mathematics, that's also how Hegel views. He says, well, mathematics is an abstraction from the reality of nature. That it's from nature that we get this the determinations of mathematics first and foremost. And sure, now we have mathematics purely abstracted and as a merely formal system, but as you said, there's a real mathematics, which is not exactly just merely the formal game that we play these days.
Mhm.
All right. Going on with mathematics. Hegel had some issues with math, famously.
Mhm.
Very controversial things. So here's one. Uh, so mathematics has become only more important for physics as time has progressed, and just science in general. Whenever we can get math to put onto something, we prefer it. So one of the reasons that Hegel didn't like Newton was that he considered Newton's way of thinking about nature too abstract, not concrete enough, and to have set up an unfortunate long-term derailment, even in his own time, of science by mistaking abstract mathematics for reality. Saying, for example, there's Newton's famous gravitational and force equations. Um, they were lauded for the simplification of complex phenomena, which is true. Now, these kinds of equations are I don't know if like you call them these, but I've read some papers and they tend to just call them like dynamic laws. Uh,
Mhm.
and so a lot of people go and say these they're laws of nature, like G or whatnot. Well, Hegel says there's a problem with these, considering these laws at all, or to be proper exhausted forms of nature's intelligibility. Uh, what is the problem with thinking that Newton's equation for gravity is to be called a properly a law of nature? Why should that matter to us?
Um, okay, so the way that I think about this is that there are essentially two main elements that are involved in the description of the types of laws that exist in nature. So on the one hand, there is the claim of universality or universal generalizability that which in nature corresponds to that of something being uh, true no matter where it is in space or time. And on the other, the the function of the phenomenon in nature itself, which is a consequence of of the specific conditions and is something more like um, the possibility or potentiality for that to be that way. Um, and in both moments in describing um, natural laws of nature in that way of universality and functionality in that sense, um, they do in one sense belong together essentially. In the mathematical formulation of laws of nature, they can take the form of laws that are aimed to be descriptively universal. Um, so, in another sense, it is all the more surprising that uh, more analytical theories have made the universal descriptiveness or generalizability of laws a more significant theme than the specific functionality of their conditions. And just a way to make this more explicit is that, you know, at what point does a, if you begin to generalize the law to more and more phenomenon, just as a way to try to capture or account for more things. There's also another thing that kind of happens is that it begins to lose out on the specific content and becomes just sort of too general and doesn't tell you a whole lot about what is what is being described. And um, at least in that sense, um, uh, another way that I also kind of think about the conceptions of laws in nature is that there is a certain ordering of explanation or levels of explanation. Like you can kind of think about there being a pure level that is, you know, a description of what the specific event is, just a pure whatness of of something that is factually. But there is another level that uh, encompasses this, which tries to examine um, how it works or what its operation is, and that is something which depends on the lower level of what there is, but just because how something functions just purely operationally doesn't doesn't necessarily also tell you um, why it exists, which for for philosophy of nature specifically, this description of proving the why or answering the why questions are given more of a priority or are more primary than that of the how or what, even though those other two things are also um, important. But the types of levels that I kind of described there in that sense are there's really no limitation in the determination of answering questions of why than just that of having reason or human reason. Um, Whereas the questions of um, how and what are more dependent on the history of the subject matter. You know, it basically the time and place in which that field of science is developing. Um, so, but the two are obviously connected and have to be connected. It's just that you know there is the concept of something uh, as it is or as it is within its time, but the concept also uh, develops and changes and enriches itself with content over time, and that's kind of the history of the subject matter and as being essentially its life. Um, and this is completely allowed for, or well, this is something that the philosophy of nature has that other more formalistic notions of what nature is uh, particularly those which are concerned with axiomatic foundations as um, not really being able to uh, account for, uh, really. Um, which, to kind of sum up, I kind of think that, what I had said earlier about the notion that basically kind of the thing that I was describing with that earlier is that there is the goal of trying to unify or maintain the unity between that of form and content. But with law or with certain notions of laws of nature can end up focusing too much on the form aspect and to the point that it doesn't really cover a lot of content or is too general, or the opposite polarity of that, where you are focusing on something that is very specific and very focused on some individual thing, but is only focusing on that aspect of it, to which why even call it a law if it only applies to that or is that one thing. um so that's kind of how I see the um
Mhm.
at least the trouble with that situation. Yeah.
Question on top of that one. Did Einstein or those who brought about the quantum revolution have any better success regarding that problem of just having a either too vague and broad universal formal view, or the complete opposite, which is like being too concrete and too individual and having no generalizable law of any kind.
Um, I think so. In one sense, I think that this is something that is inherent to the history of the natural sciences, or and also the history of um, physics. Is, in one sense, you can say that there are moments in which the theoretical work and or experimental work or contributions of uh, physicists, which come after certain in a certain point in time when there are other discoveries and inventions taking place, there is a there is a notion in which uh, there are things which are improved upon and corrected in the path in with respect to past conceptions, but uh, I don't necessarily think that, at least from the standpoint of what a specific person or specific work of Einstein compared to that of Newton or Planck or Maxwell or uh, whoever else, doesn't really uh, change much about what the about the situation that I had described. That even if the history of science, turned out to be completely different from um, what had happened, um, this general determination would it would still be true. And I don't think that uh, I don't think that there will be a specific. I don't think it's the business really or purpose really of scientific revolutions, you could say, as something which could ever really change that basic uh, basic notion of laws of nature being limited in that sense.
Mm-hmm. All right. Next question. So, might category theory, which I understand you're invested in, be a viable path to recover something like mathematical physics in the way that we currently do it? We have a very math-heavy physics today. Uh, yeah, would category theory have anything to add to that?
Right. So, um, basically, um, for those who don't know, category theory is a specific topic area in math, or a branch of math that is um, both very closely related to algebra and universal algebra, but also is um, another it is also an approach or method uh, to doing math in a certain um, way, but the focus of category theory is uh, to just kind of put it in very general terms, it is that it is it's a method of describing um, mathematical terms and objects in terms of the different contexts, which are categories, um, independently or more so focused on that than the specific um, arbitrary contents that object might or might not have. So another way of saying this is that um, eh, one way that category theory is significant for mathematical physics is that it is a way of providing a exact description of the setting or environment or boundary in which a certain physics takes place. So, like a lot of the category theory, um, even though it focuses a lot on the pure math, and as a consequence, a lot of the way that it's presented is tailored um, towards that audience. So some typical, at least at least back when category theory was first developed by Eilenberg and MacLean, that their one of their main contributions or claims or major claims here about mathematics in their own study that they, for certain algebras of some kind or type, when equipped with certain maps between them, it deserves in its own right to be as studied as studied as its own constructions, as something that as a kind of pattern that was reappearing in different in different areas of math. Uh, like algebraic geometry, topology, um, combinatorics, and others. But one oh, one very interesting thing, at least, is that in a more abstract level, one the kinds of proofs that are involved in category theory of like, for instance, proofs of equational statements are it, and maybe to put it in a more simplistic sense, are essentially equivalent to drawing a particular diagram that that satisfies, of course, certain rules in category theory, but it is very but satisfies that condition. Now, actually, with category theory, uh, in its connection to mathematical physics, you might know that William Levere, who is one of the major eminent category theorists, and he also wrote some about his own thoughts about mathematics and philosophy, and was interested in Hegel as well. He actually began his graduate work under Clifford Truesdell, who is one of the leading experts at the time in continuum mechanics and thermodynamics. And because of him, he was very interested um, uh, in the foundations of physics, particularly the notion of what a physical theory means formally. And basically, if I remember some of the history here that he had worked with, Truesdell had worked previously with Eilenberg and MacLean, who I mentioned were the founders of category theory. That Truesdell had actually sent Levier to visit Eilenberg. I think it was at Columbia. And from that time in the 1960s, he wrote a lot about what are called functorial semantics. And basically, functorial semantics is one way of describing theories of mathematical or physical objects in which a theory is described by some category C, and the model of the theory is described by is essentially a functor or a relation between categories where so for categories C and D, the category D meaning like the basically if you have in his work he was saying that if you have a theory described by category C and category D, which is essentially the environment in which the terms of the model exist. So D is often like a just a set. Um, there exists a functor that is equivalent to a model of such a theory that basically is a way of assigning the semantic terms or the basically a way of assigning semantics to the syntax of the theory, um, which you know in its own way, Levier also kind of thought of this as a unity of opposites, and he has some of his own explanation as to why he thinks this, but just as a general kind of re-summary of what I was saying is that um, it's very significant, or category theory is very significant in the formulation not only of finding specific environments or specific deducing certain models in which physical theories can exist, as well as being able to test the consistency of theories in their own right, and that is kind of maybe a more abstract way of putting it, but it basically communicates what uh, Lavier, what one of the things that Lavier was trying to do.
I did not know that. That does sound actually very interesting. Yes, all right.
Yeah.
Next question. So many seem to think that if one cannot put a math equation to something, somehow it's not very scientific. Uh, should mathematization be taken as such an important part of genuine science as it is today?
Well, my answer to this is very simple. Um, Whether or not, and this it doesn't just apply to mathematics, but whether math is necessary to something depends entirely on what the problem is. So, you know, in such a way that there are a lot of things, of course, in nature that are mathematical, uh, just by nature, and uh, at least as far as a accurate description of them can be constituted, or well, an accurate description of them can be identified in that sense. But it should not be taken to be something that is qualifying whether something is science or scientific or not, because there because this claim can easily be challenged by uh, you know I'm sure there are a lot of papers out there that are just uh, trying to over explain something in terms of math and completely miss the mark on what the problem is, and kind of get lost in their own formalization or construction that they are not really talking about anything else except the construction itself, um, which that's kind of a problem in a lot of uh, analytical philosophy and some philosophy currents in the that are closely attached to pop science. Um, I'm sure you probably know of or have encountered um, such people who believe in these things, but that is one such example, I would say, of math being used in a or abusing the power of math in order to um, make a big show of something being very sophisticated and complicated and hard to understand. And because of this sophistication, it kind of creates the illusion that, this is, there's actually some hidden knowledge behind here, when it's just smoke and mirrors.
Mm-hmm. Yeah, I remember watching. I was watching a podcast somewhere a few months ago, and they were interviewing a scientist. I forget who. He mentioned something that just sounded crazy to me. And he's like, well, like he believed that everything if it wasn't mathematically like formulated, you didn't have a science at all. So they're like asking, are you serious? He's like, yeah. They're like, well, what about biology? He's like, well, yeah. Yeah. He's like, it wasn't a science up until like a few years ago. Apparently, some people have been the mathematization of some biological systems have finally been achieved in some way. And so he says like, well, now it's a science. And he also mentioned something interesting. I hadn't heard about it before, which is something called cliodynamics, which is a mathematical theory of history. Funny enough, formulated originally by Russians, formerly from the Soviet Union, and
That
apparently,
tracks.
Yeah, yeah. Apparently, it's they've been pretty successful with predicting certain things with it. And so he mentioned that he's like, now that makes history a science. And I was like, well, that's quite something. And of course, Hegel believes that history is a science, but of a very very different kind. Mathematics wouldn't really be what justifies it for him.
Mm.
Mm.
Yeah, well, I think, I mean, I can't comment too closely about the cloud dynamics thing, but I do at least want to say that I don't think I don't want I don't want people to be discouraged from, doing their own work and invest in or using math to investigate certain subject areas just as a way of discovering things because sometimes people can actually be have a lot of ingenuity in their constructions and even if they get kind of lost or uh, come across some answers that are um, not really that strongly supported, it still also constitutes as a negative example of why an approach to something doesn't work. Because uh, even something like a, a failure of a certain model to describe something, you know, is still informative in the sense that you now have knowledge of what you shouldn't be doing or what paths will lead to a dead end or and part of that is just kind of inherent to what a lot of empirical science is kind of about. And in some ways, you can kind of try your best to be smart about it and learn from your mistakes not and not make those same mistakes again.
Mm. Now, here's one I don't know much about, but a fellow physicist asked me to ask you this. What are your thoughts on Bloch's theorem concerning the mathematical treatment of finite solids as continuous, infinite structures? What do you think of the Hegelian perspective on this would be?
Yeah, so I'm not too familiar with complex analysis to comment on in great detail about it. But as far as I understand, um, Bloch's principle is basically just kind of saying that any sort of global or general statement that you can make about holomorphic functions. And a holomorphic function is basically a complex valued function. So it's with the complex numbers that is also differentiable. So it's basically a complex function that you can differentiate. Um, but statements about them which are global, you can derive them from uh, a basically from a more local or finite uh, version of that statement. So, um, I mean, as far as as far as I understand, the principle is, and maybe I'm wrong about, but at least from what I remember in of what complex analysis that I engaged in as a student was that it was mostly a heuristic or basically a kind of rule of thumb that, a lot of, or that there were a number of, uh, you know, complex valued functions in the local and finite sense that were, that could be generalized to a more, across cases. But I don't really see, um, I don't really have a whole lot of extra commentary about what that theorem means precisely for nature. Um, uh, maybe uh, maybe a follow up on that, or something, to kind of get a closer sense uh, of what that would mean, uh,
Yeah,
in
I'm
the
not sure
specific case.
myself. I'll have to ask them. From what I gathered from the question was like they thought this was kind of an example, one of those like the infinite finite contradiction.
Okay. I I never made that connection myself, but at least like how I understood, um, the infinite finite stuff is that like, um, I mean, as far as the quantitative infinity is concerned, that is something that is already kind of uh, inherent to something in being a, magnitude. Like, for instance, if you look on the side of, the continuity of magnitude, then if you have a many that's not distinguished from a one, but it transcends limitation and being, in being a one, because the ones are one and the same one. You have, basically a kind of continuity. But if the limit is indifferent to where, but if the limit is indifferent to where it is placed, then it is possible to go beyond it because there is no absolute for quantity. So you can say that, uh, if there were nothing that were beyond the limit that the quantitative limit that is set, going beyond it shows that it is in fact something limited or finite. So the things that have like infinitely great or infinity and the infinitely small or the infinitesimal on the side of discreteness. These are just like, in my view, these are only negative concepts that, um, basically prohibit there from being a greatest quantity, because for any sort of number that you might, or any actual number that you posit, there's there's something even greater than that, or less than that, and you can just kind of go indefinitely in numbering stuff until you're blue in the face.
Yep.
That's
Well,
just
we can
kind of the
move
way
on.
it is.
Yeah,
Yeah.
yeah, we can move on to straight physics questions. So first one. So, how well does special relativity square with Hegelian ideas?
So I would like to make the unique claim. Um, I don't know how many other people also make this claim, but that there is a consistency, but with both, but understanding the reason as to why this the case requires some background and explanation. And basically, the way that the case that I'd make here is this. Um, so one major consequence of the turn towards special relativity, back originally in 1905, was the non-relativity of the motion of light. And its a result is something that is proved to be quite paradoxical. In contrast to the general concept of relativity in motion, which goes back to Galileo, and arguably even as back to Aristotle, is that in the theory there is what is maintained is that there is a velocity of light or the speed of light is something that is an absolute. Relative here meaning dependent on a reference frame, and absolute meaning independent of any reference frame. It's kind of a strange fact that, if you have like a absolute velocity already being shown um, uh, as a consequence of Maxwell's equations for the propagation of electromagnetic waves, in which it, it appearing to be something that is something at least in the theory is something that is constant and so independent of the reference frame, whereas velocity purely as a classical concept is really just a prototype of relative quantity. And what was confusing, or the confusing situation was for Einstein, and this is something that is very much independent of the Michelson-Morley experiment, is that even from an a priori kind of point of view, that one of the major motives for the development of special relativity was in improving the relativity of uh, normal or usual motion of bodies and the absoluteness of light to be something that was or is mathematically compatible. But from this point of view, the absoluteness is something, of course, is something that should be clarified too. At least in the way that I see it, or the argument that I kind of put forward here, is that with respect to the concept of motion, in the way that Hegel describes it, the logic that is in the concept of motion requires that something that is must exist, that motion refers to, and as such is determined relative to rest. And at rest, meaning here that something is identical in motion, or that rest is itself connected to motion in the beginning. So the kind of unity of rest and motion is empirically realized in the mass of a body, results in basically the concept of motion, which Hegel says specifically, and I have a quotation here, that the mass is the unity of the moments of rest and motion. Both are contained in it, or it is indifferent to both, and capable of both motion and rest. And so Hegel, he brings this, he connects this to this characteristic later with inertia or static motion, but in basically really the thing that is to be considered for relativity, or the relativity of motion, is the purely kinematic aspect of it. So like the mass can be considered indifferent to rest and motion or inertia, so to speak, and thus as well as to resting and moving. And that is essentially the basic content of relativity in the kinematic sense. And basically from this, you can kind of draw like three things. The first thing is that the principle of the relativity of motion is not simply that motion is always relative motion, because even in that form, it would even be empirically false in respect to the motion of light. Rather, it contains the statement that a moving mass can be considered at rest with the same right, and vice versa, a resting one that is moving. So kinematic relativity, basically understood correctly, is the relativity of the motion mass. And thus considered, motion can only exist relative to a resting instance of, or reference. But for kinematic relativity, the relation of rest and motion is already symmetric. So we're dealing with already a relation or a relative motion between that of masses. So you can kind of say, this is another way of saying that there is a kinematic equivalence of all mass and motion. But you can also, secondly, deduce that you can see that a mass can always considered in a certain sense resting as well, because for kinematic equivalence, it's essentially based on the ability or for masses to be in a state that at which they are, so to speak, at relative rest, and this is relative to, an instance of motion. And thirdly, you can also basically say that for the motion of mass being equivalent to relative motion also implies the motion of something that is non-massive, whatever that may be, is also being relative motion. And really, this is necessary, maybe not necessarily trivial, but it is kind of a consequence of what is even in the study of even generally in classical Galilean relativity, at least from the standpoint here that the concept of relative motion is not really not really a contradiction to relativity, but it's implied by it. but of course, you can maybe object to this and say, what does it mean for something to be non-massive? Uh, you know, I mean, even if you go to Hegel, he gives some reasons, a little bit of reason about um, why something of this kind can exist in nature, and he even identifies it with light directly. Um, you know, Empirically, it is the case that light actually has energy, of course, but it has no um, rest mass. Rather, light is never really uh, it's always in motion. But according to what has been stated, there cannot really be motion is only motion with relative to a reference realized by a mass, but it in that respect, uh, light kind of becomes essential here because it doesn't have uh, even empirically it doesn't have a rest mass, so it is no longer a purely reversible case as between kind of a alternating back and forth of relative motion between masses. But eh, you know now that means that mass basically doesn't really have a defined state of motion relative to light. And in fact, basically, independent of what that state of mass may be relative to another mass. So you can kind of state this more generally in that the kinematic relation between that of mass and or rest mass and light is identical for all masses. So what this would mean logically is that the speed of light cannot really depend on be something that is dependent on the state of a mass in motion because it's relative to another mass. So that really means that it has to be uh, the same in terms of its speed relative to any mass, independent of its um, state of motion. So it, in this sense, it can kind of be seen that the notion of light as a non-mass or something that is almost uh, a kind of negation of negation is a motion that moves independently and is not relative to any um, motion. And even just logically, you can see, well, what if this weren't the case? Well, okay, if it weren't the case, then that would mean that the speed of light would have very different values with respect to any reference instance or any reference in motion um, moving relative to each other. Um, so basically, but this would kind of oppose the fact that you know light being or not having like a rest mass. Um, but according to this kind of uh, interpretation of relativity, you could say of the motion of mass being already in some sense equivalent to relative motion, then the speed of light have being non-relative or independent in its motion uh, kind of follows as a direct consequence of this. So kind of like basically this whole riddle of non-relative motion being on the fact that motions in daily life are basic, almost always of the time, motions of mass, and therefore relative. So, in that kind of sense, a notion of absolute motion is something that kind of seems um, unusual because it's not really something that is quite different from other things being in motion and already being moving relative to other things. Um, so and in that sense, you can also say that the speed of light being a a kind of essence or identical quantity for any mass that is in motion is something that is a comprehensive characteristic that is in common to any particular point of reference. As kind of a way of describing that why is this specific to light and not other things that are in motion. And I also think that this is in a certain sense as to why light, or very specifically light as ontologically, is something that is quite almost transcendental to general motion or the mechanics of motion. And even though that Hegel doesn't really explain this specifically, well, he has a reason for it, and perhaps I just don't remember, but light is definitely something that is in a certain sense is always active, is always and in that sense is almost kind of in a certain way the natural objectification or corresponding objectification of essence in the logic. That, as essence kind of being something that is purely indifferent and always non-immediate to determinations of being. And that's kind of a comparison that also kind of exists in my own writings, that there is a correspondence between Hegel's mechanics as basically like math, analytical mechanics, and basically like math, dynamics, and like astronomy as is kind of being purely in that realm of simple, more purely quantitative, mechanical motion, and light is actually kind of is essentially transcendental to this. But that's kind of the way that I've been trying to think about it, and there's obviously there's also more than one interpretation that exists for general relativity. One such interpretation that I kind of favor is uh, at least the way that the equations almost kind of imply that uh, or at least formally the equations almost kind of imply that space itself being an almost polarizable medium, and because of this kind of um, electromagnetic deflection or deflection of light is basically kind of what creates the appearance of light bending and slowing down. But it's kind of really more of a phenomenal effect that is observed by us, um, basically from our own standpoint.
Well, let me say, I did not expect you to go in that direction. The usual thing that people talk about is the space-time relationship with special relativity. So that was definitely something new. I'll have to listen to that. That is
Yeah,
interesting.
yeah, and I'd be happy to explain more things about it, because I know this is kind of like just an AMA, and it's hard to. There are certain questions that I think that are, it's. I mean, I can obviously try to give my best, a within a reasonable amount of time, but you know, getting into the details is what really matters in getting in understanding these arguments.
Yeah. Shifting to quantum mechanics. Uh, do Hegelian modal considerations forbid the many worlds interpretation?
Uh, oh yeah, absolutely. It is. I mean, well, okay. The reason that the many worlds interpretation cannot be a true interpretation of quantum mechanics is because it does not make any sense to say that reality exists only as. I mean, there's a few ways of ontologically treating it, but the major ones are, it makes no sense to treat reality as a infinity of worlds that are all equally real and have no other such you know, interaction or relationship to each other, that in a way it kind of assumes, uh, at least in the way that the problem is kind of, it's basically the same problem that is ontologically speaking is, in the science of logic, there's the whole problem of the, you know, the being for self, or being for itself, and that of the one and the many. And basically, the many worlds interpretation, it doesn't really make sense logically, or from the purely from a conceptual standpoint, in that basically it basically asserts multiplicity or plurality over and against unity and totality, when it in fact presupposes the existence of those terms in determining that. Now, to and there is also another way that you can kind of treat this, that in a modal sense, of in terms of a modality. Like, it doesn't make any sense logically to say that, all possibilities are actually all actualities, and that there is actually a multiplicity of uh, possibilities that are actually actualities, because then it kind of generates an impossible situation where you know you don't actually even know what is actual, or what is even actual anymore, because everything is just kind of treated. Um, he's like, oh, all of these things are actually possible. They're all actually real. Um, now, and this is something that's just kind of weird to me, because it's not like it. I mean, I've read some of Hugh Everett's uh, work. I mean, clearly he got some things right, in my opinion, as far as the wave function being something that is, um, uh, that the there is no real like there isn't really a collapse problem if the wave functions exist uh, conditionally, and that if quantum mechanics is actually a smaller subset of a wider um, dynamics, that is only a limiting case of, basically, like, there's only a limited case where that probability of quantum mechanics actually works, and where you can actually like assume the Born rule for probabilities, and that is something that you know exists but is partial and not really um, the full physics, and is actually grounds for exploring new physics. But Everett does also have some other interesting things where he talks about there being a universal wave function and a hierarchy of wave functions. But you know, uh, basically the kind of problem that he does, or at least I don't really think he realizes this, is that um, why it isn't just a problem to consider a possible world as just a pure possibility with reference to conditions that exist relative to the present. Like, there's basically no need. Like, there's a way that you can talk about that and describe that, and there are some theories that are do a better job of this. Uh, in my opinion, the non-local hidden variable theories are more successful in that respect. But for the precise reason that they don't really treat um, they don't have this extra semantic baggage about um, arguing that you know all of these infinite branches of reality are all actually actual things. And there's a very simple fix, would basically just to say, there are possibilities for things to be in the present. And it you know uh, someone who comes at this from a many worlds perspective would basically just say, oh, why are you basically saying that there are like empty branches of like world lines and things that don't kind of exist? And it's like, well, what do you think a possibility is? Like, a possibility is something that is purely inner, and does not have an outer. Uh, and this is kind of something that to goes back to Hegel's description and the science of logic, where he talks about uh, possibility and contingency in the doctrine of essence, where basically, um, you know, a possibility is something that is stipulated or posited purely as something inner. So like when we say that something is possible, we have in mind that there is some basically a thought of something that is not real or not yet out there in the world. Um, like a if you like someone who has an idea for a business, that is a possibility rather in actuality, because there's no business that is out there that corresponds or is related to that idea. Um, so whereas on the other hand, you kind of have the opposite problem um, with so with the many worlds, basically I would say is that it mistakes the inner as already actual and denies the outer. Whereas the problem with uh, the Copenhagen view, or kind of the uh, or kind of like the a purely instrumentalist view of that, it's just a probability, is that it reduces, or it basically takes contingency or the outer as something that is only actual while excluding the inner. But they're both things that are one-sided and fail uh, ontologically as interpretations, in my view.
All right. Yeah, I agree. Let's move on to just the final section, specifically Hegel stuff. So in Hegel's philosophy of nature, the derivation of the dimensions of space stop at three. Is there any reason why we should stop at only three dimensions? Does Hegel explain why, or do you have any inkling as to why, or beliefs otherwise?
So in Hegel's description, um, and I agree with this description, is so the most elementary category of nature is space as a self-externality. In its most abstract and immediate form, it is just externality. So in determining, so to further determine what space is as a concept, you essentially you posit what is spatial, or basically what is spatial is what is localized in space. So in a kind of rough generalized way, you can say that the point is something that is posited in space as the negation of space's externality or exteriority. But since this is at the same time something that is without extension, because the point is not extended, it's just a point. So it's purely local, it's in space, but it's also at the same time a kind of negation of space because it's not external. So you with the concept of the point as something that's non-spatial or non-extended is something essential if you want to determine basically in a more concrete way the character of what space is. So it's a false conception that points are also elements of space because as stated earlier, there's, it's impossible for the point to be extended if it has no extension. But in the negation of spatiality or extension, the point nevertheless relates back to space by distinguishing itself from it. So it also, in a certain sense, ends up defining space by functioning in a certain way as a limit to it, as something that is the non-spatial or the negation. But that at the same time, a point can only really explicitly be a limit to something if it is in relation to extension and is something that is linear to it, like the point in relation to another point. But the point in relation to another point is something extended. So the basically this construction of this is the construction of the line as something that it's extended, but it's also limited by the points, by the points at each end of the line. But in that transition, you have something already kind of implied here that because a point is divided, or basically the point kind of limits a line, each of those parts of a line has two sides of that line, or there's one end of the line and then there's the opposite end, so the line has opposite ends. But this polarity is not something that was present in the determination of the point as negating it. So this can only be really limited and taken for itself if the line, for the line is negated as a line, and the point is taken to be a point of intersection for any number of lines. But this means that there is now another determination of space, basically with already the intersection of lines already implies another determination of space in which lines exist or are spatially extended in or across something, which is the plane. And then you have the plane being already developing out of the point and from the line as also being a point of limitation itself, which, because there is an original determination of the point as limiting space, it is now realized without the deformation that point has in the line. Or put another way, only that which is limited by the plane as a surface is really a fully determined space, or is a fully complete spatial structure, where when you have the plane being the surface to another, uh, to be something else that limits something that is extended as a shape, or as a geometric solid, or three-dimensional shape. Um, so in a way that, and in kind of replying to the possibility of there being more than one spatial dimension, I would say no. So while it's possible to construct, or at least describe things mathematically in terms of higher spaces, only three-dimensional space is a fully determined or complete spatial structure. So, if you want to talk about any sort of space that, oh, we're actually sort of describing this in higher dimensions, you cannot explain that, or those higher dimensions cannot be explained in terms of any other dimensions that are higher than 3. Because even in talking about, like, um, 4-dimensional or 5-dimensional spaces, what have you, you can only really show them as a result of, something being projected down from, or essentially by analogy. The whole kind of typical sort of analogy that is given is that of things living in flatland, and that, we can't really see what's kind of beyond. We're just sort of seeing the projection or shadow of something being cast from a higher dimension. Um, but but any description of a space that is more than 3 dimensions is basically just an iteration, a repetition, you could say, of 3D space, and not as a meaningfully new or different structure. You're basically just sort of multiplying mathematically those different spaces, but you're not constructing really anything new beyond 3D space, because it's already complete. That's how I would describe it.
That's very interesting. I hadn't thought about it that way. I mean, I had thought about it in the way that there's no reason to go beyond 3. I mean, for everything that we experience, there's really no reason to appeal to anything that's beyond 3 dimensions. I mean, there's people who
Well,
certainly
that's
try.
that's also true. Yeah.
So that's my usual answer. Um, all right, for time, A theory, B theory, C theory, or none of the above. Which one does Hegel's speculative philosophy of nature side with? Or all of the above?
Uh, so let me just re-familiarize myself with this, because I'm. Let me see. Um,
Yeah, I think A. Well, I forget which one it is. One's linear, one's eternal, and the other one's kind of in between.
uh, so I would basically say So as far as Hegel's, to just kind of preface this to, and perhaps the answer to this will kind of follow naturally from this, is that the way that Hegel talks about time and how I think about it as well is that for time, time is really nothing more than the vanishing of the there-ness or being of space. It's something that is purely negative in the sense that each moment of time negatively posits what comes before and after itself, but because it is only a moment. So like the here becomes the now, and the moment is something that is so brief and ceases to be and is replaced by another moment, um, and so on. But there then becomes a relation between moments, or as essentially something that is duration, and the idea that something persists in time or is uh, lasts in time as something that is basically analogous to the construction of the line from points in space. The duration and moments or nows is something that is uh, or the similarity exists there. But there can be, but since it is this pure negativity, it is each now replacing the other. It produces a new now through by annihilating what came before. So logically, there can be no first now that is not then replaced by which is not begotten by its predecessor, just as there's no last now that is not destroyed by something come after it. So, and this is kind of something being that, you know, uh, there is also a similarity in time as far as there being a beyond to time as being similar to what I talked about in with quantitative infinity earlier, that there's a kind of saying that there is something that is absurd because before and after are precisely categories of time. So the dimension of time, the so-called arrow of time, why is time proceeding in a certain direction and not in the other direction, is that that's just the way that time is constructed. It's nothing more than this sort of pure unfolding or change, as kind of a basically the pure negation of coexistence, because there is no now that can exist alongside another now. It must always strive to go uh, out of itself, or to negate the coexistent, because there wouldn't be anything other for time to negate. So, and basically from this you can kind of already uh, understand the meaning of the past as basically the existing now that passes away or ceases to be, and the non-existent now that uh, that will come to be as basically the future. So you can kind of see that future and past are in this way not really, they're not really determined as beings, but they're more purely a processes or process. So basically, like the non-being into which the past sinks is the same non-being from which the future arises, and that being that passes away in the past is the same being that the future. But from this, you can already see that this thing that precisely stands between the past that no longer is and that is not yet is, well, the present. But it doesn't purely stand. It's not merely something that is in the middle, or you could say the mean of past and future, but it is also the very boundary or limit the past and future are distinguished. It's the same indivisible moment in which the past becomes as being the present itself. Uh, so that is, and you know, obviously you can kind of relate this back to um, in a certain way. Uh, I think that I mean, obviously to take what Hegel's reason is and what argument he kind of states here, um, to essentially logically sort of eliminate or see what theories of time kind of agree to this or do not agree with this, um, would take some time to check. But I think Hegel's view is more unique in that respect, and should be really should be taken to be its own position, because um, you know, to say that, an eternalist or is presentist, or does he believe in A, B, or C theory, or growing block, or whatnot. You actually you um, like Hegel has some very precise terms for what exactly he means by, you know, what it means for the past, present, and future to exist, or what its existence means. Like, obviously, there is a sense in which all of these are real as concepts, but, you know, uh, it kind of gets into the same situation of, because the past and future are actual as processes, as part of, basically, you could say, the two sides of time's restless negation, as um, kind of positing and presupposing the other. Um, and the fullness of the present kind of embracing sides and aspects in the same way that existence or determinate being does for both sides of becoming. As what does it really mean to say, like, is the past more real than the future, or the present being all that there is, and that there's, you know, the past is something that is only like um, a memory, or exists in memory, and the future is like you know something that we anticipate or sort of intuit, um, which that kind of gets into some um, semantic baggage from also needing to explicate some kind of um, uh, psychological theory of how the brain experiences and processes space and time, which is basically a different question, as I see it, um, and not really um, pertaining as much to nature as it does to mind.
Hmm. So, last question. Hegel says something weird. He says that the truth of time is a circle. Uh, and then he gives a geometric example of it, to show regarding the spaces. He says, well, technically, if you look at it as the externality of space on a circle, each point is the future of some other point, and the past of some other point, itself its own present. Um, how do you interpret that? How can you explain that?
So, at least the kind of way that I see that is, there is a complex relationship between that of time, eternity, and the concept in general. So, um, basically, if you kind of think about what something of what truth has to be, that it be universal, necessary, and something that applies you know universally, and eternally. But paradoxically, also truth is in time, and within the world. So it kind of, there is a connotation, that uh, truth always being conceptual, as in uh, the totality of coherence, being in the concept. But that raises the critical question: what is really the relationship between that of the concept and time? And Hegel very said, too, in the philosophy of nature as well, that time is the concept itself that exists, which exists empirically. You know, um, there and there are some different, in comparison, some different ways to thinking about the relationship of the concept to time. You might have something like, uh, if it's something that is purely eternal, as something, um, basically something that, um, is more of a Spinozist claim, or that you know another viewpoint being that, because the world is always changing, that there is almost kind of a tacit rejection of you know some stable meaning, because there is kind of always this sort of change. And there are also other um, perspectives on that. But compared to Hegel's that of equating the concept with uh, uh, time or the externality of the concept in time, it is something that unifies both the reason or the actuality of reason in how we engage within it in our own time and the historical development of the concept itself. So, in a certain way, you can say that existence or determinate being or uh, design itself is something that already has change in it or has change as a part of its definition. And time is something that is, the objectification is basically this kind of change or becoming existing in the world externally. So the concept, while being something that is eternal, um, becomes empirically real when it takes or when it appears to the form of human reason and intelligibility. So, so it's perfectly consistent to say that the concept exists in time and as time in history. So, and this kind of, in a sense, provides a solution to the kind of problematic conception or the problems in the conception that might say, um, of Plato's notion of eternity being something kind of transcendental to this sort of thing, or Kant's point of view that experience is just kind of structured through categories of the understanding, and that being and thinking are united. That he doesn't really explain or deduce how, in fact, that they are uh, united. And actually, because of this, it's because of this identification, the eternity of time is actually what makes knowledge or absolute knowledge possible. Because if the concept realizes itself temporally or in time, then it can evolve and develop. It realizes itself in history and becomes what it is, you know, as the truth. And there is kind of a metaphor for this in the uh, at least in how I think about it as well, is that you can kind of think about this in terms of the biblical meaning of the word, like the logos, the eternal concept being manifested in intelligibility, also simultaneously through a counter movement becomes eternal and therefore allows eternity or the infinite to be expressed in the finite, the present experience of time. And this basically this dual movement or dialectical is actually what is involved in the generation of truth, or truth's own self-generation. And without the word or logos, then basically this eternity would be totally inconceivable to human reason. And without this eternity, you know, the notion of the logos as logos would be something relative and, not absolute, something only partial or incomplete. So, um, you know, this is something that, uh, and this conceptual understanding is really only through, um, you know, the philosopher using their own human reason to comprehend reality in their own time. Uh, so in a certain sense, there's also a deep connection to that to man and humanity, like time not being just some sort of um, pure container in which sort of things are kind of collected, but time also really being the concept as it empirically exists and unfolds and becomes. Um, and Hegel also says that spirit is closely connected to time as well, or really that the spirit experiences time as a kind of memory and idealization that you know as a one kind of way that the difference arises between nature and spirit is that you know nature doesn't have this interiority and pure act of reflexivity and self-causation that spirit has. So, and spirit is really this interiority. So it doesn't, or it basically is able to idealize, um, recollect or recollect natural moments as part experience, um, experience in time. So basically, there's really no like externality between the concept eternity and time. Really, there's they basically kind of form a hypostasis, uh, or as different parts of the same thing. Really.
On that note, that's it for all my questions. Is there anything you'd like to let your fans know? And by the way, you do have fans. I don't know if you know this. I have seen you randomly mentioned around Reddit very enthusiastically by certain people as well as on Discord on other servers. So
Oh,
you have fans.
I've no idea about this. I've I am kind of I mean, obviously I am motivated to um try to reach out to like make Hegel and Hegelianism simpler and more communicable to the extent that that's possible. But in my own work, I can kind of become more so focused on it that I don't really pay as much attention to like the whole world of things kind of going on. But it's really cool to who are like enthusiastic about this. I know at least as Reddit is concerned. I know that uh, the Blitzen or Faint, as he's sometimes known by, has posted on there before about some of my stuff. But yeah, I actually I didn't know that there was some. That's really cool. But as for some things to say, um,
Yeah, what do you have in the pipeline? Anything you're gonna publish anytime soon, or you're working on that's interesting?
so I am basically doing a complete or I've been working on this for like the past year of basically a complete overhaul to the speculative science website that as of now it is mostly was just mostly some notes about like uh, the science of logic, which you know basically are kind of my past writings back into in like you know I think 2021 to 2020, which some of the stuff is a little outmoded as I some better um, longer explanations for some of those things. So that will get kind of a new addition to logic. And I also plan on posting some uh, very much completed and of the same caliber in the flop that will be out soon. And I've kind of just sort of been working on it for some time. Uh, the sections to the that those are the current things I'm working on. I also have something for the philosophy of spirit planned. That is kind of more up in the air. Um, just because it has already taken so long working through logic and nature that uh, some of the things about philosophy of spirit, um, I have my own kind of take on things. As far as like practical philosophy is concerned, as probably compared to a lot of at least in comparison to a lot of other Hegelians, um, uh, I'm definitely more left wing or progressive in that sense. So, but I try to be like I have my own sort of version of how I think practical philosophy is, and it basically kind of like that there ought to be some type of uh, descriptive unity between that of both sides of uh, individual right and social right, or between that of like personality and like association, and that's kind of something that is um, inherent to political life and uh, very much something that uh, I think really should be uh, cultivated in that sense. Like something I'm very passionate about is kind of the Athenian sort of conceptions of you know uh, statehood and what it means to be like a citizen and things of that nature. Um, but as of now, that stuff will probably come later, because one, I still have more things to kind of work through in the encyclopedia, and that specifically will kind of is in the works, but will come later. Um, but those are kind of the main things that I'm focusing on. I have ideas for like um, other things, but those also kind of, I mean, for other um, possibility for like articles and papers and stuff. But I've been very, very focused on getting the encyclopedia stuff out because that is really the most important.
All right, Avalonia. Thank you, and I'll wait to see those things. I like your stuff.
Yeah, thank you. Thank you so much. It's a
All
pleasure.
right, so see you around.
See you around, man.